Okay, YouTube, in this video I'm going to share with you basically some techniques that you can use when solving equations that involve algebraic expressions in a ratio. Okay, so rational equations, basically rational expression equations. In the past, when we've looked at equations that have fractions in them in the first place, one good method in algebraic equation solving is to just eliminate the fraction altogether. So when we talk about eliminate the fraction, this is basically going to be our goal here. Any fractions, what we're going to do is we're going to multiply through by the least common denominator everything. Okay, multiply everything by the LCD, the least common denominator. Okay, and what that's basically going to do here is, if you were to take a look at this first equation, we have 2/3 of an unknown value plus a half of a constant equals 9/2. What is this value? Well, what we want to do is we say, what's the least common denominator between 3 and 2? In this case, we'd say, well, of course, 6. If we were to take everything here on both sides, and it's got to be everything, times a 6, we would interpret this 6 as being over 1. And what I want everybody to see is instantly, at least on the right side, that this has to happen. You've caused it to cancel out directly and leave nothing but 1 in the denominator here. Now, this 6 would turn into a 3, and we'd have 3 times 9 is 27. But essentially, you would eliminate the fraction guaranteed, because we know that these two things in the denominator are factors of this least common denominator. So if we were to multiply the 6 through over here, you notice that the 3 would cancel out, become a 1. The 6 would become a 2, and 2 times 2x would give us a 4x. And then the 6 times the 1/2 here, the 2 would cancel out, give us a 1. But the 3 would become a 3, and 3 times positive 1 here would give us a positive 3. At this point, we could just go through this and say, well, this is a two-step equation. We'd boot this constant here, and we get essentially 24, and so this implies that x equals 6. And I think it's really important that when we're doing problems like this, that we go back and check our solutions. We're going to see sometimes that we get extraneous solutions, or equated, solutions that work algebraically, but when you plug it back in, don't come out to give you a solution. So 2/3 of 6, which, by the way, we could say this is a 1, this is a 2. 2/3 of 6 is 4. So we say 4 plus a half equals 9/2, and of course this is very true. So we did get a solution here when we said x is equal to 6 is our only solution in that solution set. So let's take a look at this next equation. This is really the crux of the matter. Maybe for the first time you're seeing a rational set of equations here, or expressions that are equal, and the unknown is in the denominator. So what we're going to do, our method, is going to be, we're going to multiply both sides of this by the least common denominator. And looking at this, we'd say, well, what would be the least thing they have in common? I notice that this has a 2. These two would need a 2 also. These two both have a single x, in their basement, but this needs an x. So I'd say 2 times x, I would say, is the least common denominator. I'm going to take both sides times 2x over 1. And what's going to happen here, essentially, back over my pencil tool here, 2x over 1, is that we're going to get factors to cancel out. Again, like on the right side here, I would say that the x's cancel out completely, and I get 2 times negative 11 is negative 22. And on the left side here, in this first distribution here, 2x times the 4 over the x, the x's cancel out. We get 2 times 4, which is 8. And we would say 2x times positive 5/2 is positive, and the 2's cancel out this time. We get 5 times x. So solving this, subtracting 8 from both sides here, we would get 5x is equal to negative 30 constants, and this would imply that x is negative 6. And again, checking this, if we were to plug this back into the original equation, we say negative 6 in for x here. We say plus 5 over 2 is equal to negative 11 over a negative 6. It looks like we get 11/6 positive on the right. And then over here, we'd say this is a negative 2/3. And if we were to add thirds plus halves, we'd say 12ths. So we say negative 8/12 plus, take these times 6, we get 30/12. And you can see how this comes out to be a 22/12 over here, which is 11/6 once it is reduced. So this does indeed work, okay? So I would encourage anybody watching this to try this last video on their own and say, well, what's our least common denominator? And, it looks like I've copied and pasted the same one twice here. I do believe that I still have this up, and we can pull this open here. But I wanted to pick on this guy here, I believe. Yes, okay, so we'll take a look at this example number 2 here. We'll drop it into the canvas. Whoops. And what you're going to see here is a situation where it looks like you have a whole value, WHOLE. And so this kind of intimidates people. They say, well, how would we deal with a situation like this? And in a situation like this, our method is just going to be to drop this over 1. So factoring everything here before we solve this here, we say, is everything factored completely? We say, yes, the denominators are at least factored completely. What's the least common denominator between everybody? And it looks like it would be the product of 1 and these x minus 2. So we're going to take both sides times x minus 2. The important thing is that we're taking it times that entire factor. So what's going to happen here is when we do this, on the left side at least, these x minus 2's cancel out and we just get left with 5x. And on the right side, we're going to say 7 over 1 times x minus 2 over 1. We have to distribute that through. We really get 7 times x minus 2 all over 1. And then we would say here plus, now these x minus 2's cancel out here, we get left with 10 times 1 over 1. So 10 times 1 over 1. Essentially, we get no denominators left over, no fractions. And we get left with 7x minus 14 plus 10 on the right. And when we combine these like terms here, we would end up with, looks like a negative 4. So let's go ahead and solve this now. If we were to say, let's say take our 7x over here, we'd say 5x minus 7x is negative 2x is negative 4, and we would divide both sides now by a negative 2. So we would determine that x is equal to a positive 2. I do want to make sure that this works here. So if we plug it back into the original expression, we had 5 times, this would be a 2, all over 2 minus 2 equals 7 over 1 plus 10 over 2 minus 2. So my only issue here with this is the fact that we get zeros in the denominator over here. So you'll notice that I've titled this solving an equation with an extraneous solution. What I wanted to point out was basically that when you're multiplying to get rid of fractions here, you're basically manipulating this on purpose, manipulating the variable in such a way that algebraically we were able to discover that it's algebraically sound to say that x equals 2. But it's actually not really the solution when we check it. So always check your solutions on these. Cheers.